Welcome to the Naperville System Center virtual user group meeting today. I'm Frank Lesniak, and I'm kicking off the event this morning. And I guess before we get started, I just want to quickly thank Amy, Andrew, Matt, and Johan for inviting us to speak today. We have a great set of content and speakers lined up for you, and we're going to be getting started with our first session, which is entitled Branching Your Way to Glory, Source Control for the Systems Administrator. That session is going to be co-presented by me and my colleague David Wiggs, who I'll introduce in a moment. Following that session at noon Central, we'll have a session presented by Johan and Amy, and that session will be providing you with an update on what's happening with Windows 10 and Config Manager. And then finally, my colleague Tom Gould and I will present a session on mobile device management. It's called Securing Mobility, the Dilemmas of a BYOD Mobile Workforce. And that session is going to start around 1 o'clock p.m. Central US time. To get started, I want to just quickly introduce myself. I'm Frank Lesniak, and I'm a senior architect at West Monroe Partners. My focus is on cloud and infrastructure, and I do a variety of Microsoft projects kind of all over the map, to be honest. But I think what I want to talk about that's a little bit more fun is just a couple of quick interests. Number one, I do a lot of work with RetroPie. I think it's a pretty fun platform for retro gaming. It runs on Raspberry Pi, Linux, et cetera, so it's a little bit different from a systems management perspective for me. And also, I do also a bit of work with an animal shelter that's local to DuPage County. So you see in my slide the hashtag SpaceCat. I think that's just kind of a fun little promotion I've got going on at the moment. And then kick it over to David.
Hi, I'm David. I am a senior consultant here at West Monroe Partners on our cloud and infrastructure team. I have been doing some PowerShell stuff since about 2012. In all seriousness, though, I am extremely passionate about this subject and done a lot of research in the space, and very looking forward to sharing some of my thoughts today. Outside of kind of my IT career, I really enjoy math. So if you want to get me talking at a bar, just go ahead and ask me some questions about linear algebra. Or I just got back from Cape Town, so happy to tell you about my experience there. But without further ado, we will get started with our session on branching your way to glory, source control for the system administrator. So the agenda today, we're going to talk about first maybe the motivation of why we need source control. It's not necessarily apparent for us as system administrators. And because of that, we're going to go over some source control fundamentals, define some vocabulary and some workflow items that we'll actually demo later in the session. Prior to that, we're actually going to show you how you can actually configure Visual Studio Code to integrate with Visual Studio Team Services. And we will actually conclude the session with some next steps regarding maybe more bigger picture architecture as well as some licensing implications. And so with that, we'll go ahead and get started. So when looking at this internally at West Monroe, actually, we wanted to start off with identifying some of the limiting practices that were currently in place for us that basically were preventing us from scaling. And some of those ideas were basically that we were keeping some scripts within functions rather than using a functional library. We were maybe using a PowerShell profile to store functions. And maybe at the worst scenario, we were using Notepad++ to actually develop our PowerShell scripts rather than a proper development environment. And so obviously these have significant impacts on our ability to scale and increase adoption for our PowerShell development. As I said, we have disparate functions. We have local profiles limiting knowledge sharing. We might not be using the best grammar, and I'll use air quotes there, or syntax to develop in, making it a little bit more difficult to maintain and follow scripts. Also, having a lack of backups by having scripts being saved on a local machine was something that we identified as definitely not optimal. So when looking at all of those inputs, we realized that the solutions that would alleviate these problems really center around utilizing a centralized functional library, dot sourcing functions, as well as standardizing the development environment as well as processes. And source control is actually the exact vehicle that'll get us to that optimal state.
So David, before we move on, I want to make sure that the audience really understands what you mean when you say functional library dot sourcing. Can you maybe just take a second and explain that? Because I'm not sure everybody's experienced that before.
Excellent. Yeah, that's a very good question, Frank. So functional libraries are basically, it's just the same idea. All functional libraries are contained within a .ps1 file. But basically right now, let me see here, see if you guys can.
Can you bump up the font?
Yeah. Let's see here. make sure you guys can see here. Does that work a little bit better for you? A little bit more.
Yeah, that'll do it.
There we go. So right now, for example, I am in just my user directory right now, and if I wanted to call a function that I've defined in a functional library, get GeoIP, this is not a function that's going to be recognized by PowerShell at the moment. However, if I change directories, or if I do an idea called dot sourcing this functional library, which I can show you what the contents of it actually looks like. It's essentially just a PowerShell script. You can see how we have our function wrapped in our code block here. So if I actually do the dot sourcing by just literally typing a period and then making sure that we go to our correct directory here, what that does is it allows my session to now call the get GeoIP function. And I think it might still be on my desktop. No, but if I had a regular IP address that I wanted to check the information on, yeah, it's probably not going to find this IP address right now. But essentially, it allows me to call that function within my own session rather than relying on my profile or some other means to call that function. So it's really about just the dot sourcing capabilities of PowerShell is something that is fundamental to source control in this environment.
And I think what's really cool to imagine is you can have, these functional libraries call other functional libraries, which call other functional libraries, and that's how you can really build up, kind of this library of content.
Exactly.
That you can reuse.
Yeah. So as I mentioned, source control is going to be the vehicle that we use to get to an optimal state. Increase our knowledge sharing, being able to develop in isolation and all those ideas. But when we looked at some of the source control providers out there, we really settled on Visual Studio Team Services. Visual Studio Team Services was renamed to such from Visual Studio Online. And basically the reasons why we chose to go with this is, for one, it integrates with Git right out of the box. And Git is obviously the industry-leading source control engine. There's familiar workflows, whether you're an advanced source control or a software engineer, or if you're just getting started, it's a great place to begin at to learn. Also, obviously, being a Microsoft product, it has directory integration with your Azure Active Directory. Utilizing those identities, you can place access control on different branches or files, as well as the reporting capabilities allow onboarding to be extremely accelerated. So user adoption goes up extremely, we've noticed. Lastly, Visual Studio Team Services has a native wiki integration, meaning that for each project that you have, you can essentially centralize all your documentation. Whether it's to the steps on how to develop in a proper way with syntax. Maybe there's a legal banner that you want to include. There's other. The possibilities are endless. Like with any wiki, you can have a page for whatever you want, and then it gives you that single pane of glass for each project that you're working on.
Definitely.
Yeah. And so now that we know that we're going to be using Visual Studio Team Services, we'll go on to kind of some source control fundamentals. Starting off, firstly, the idea of a backlog is something that we want to define for everyone. Now, being system administrators, we typically view a backlog as an analogy to a ticketing system. A backlog is essentially a list of stuff to do, much like tickets are, except a backlog you can be a little bit more specific in categorizing these tickets or these work items. Specifically, there's a couple of different types that we work with. One being a bug. A bug is something that would be utilized if you're going to be addressing a functionality issue. Maybe something's broken or not providing the right output or input. That can be compared directly to a product backlog item. Product backlog is maybe more about if you're going to be introducing a feature enhancement, or maybe you're turning a script into a function. Though that's the descriptor that we would use in a backlog to define those types of items. Effort is pretty much straightforward. This is probably where you'll get a little bit into some philosophical debates with your software engineers about how to actually tag effort. The moral of the story is that the lower the number, the easier the effort, and the higher the number, the more duration or the longer it might take you to complete that work. Again, you can use a Fibonacci sequence, you can use a base 2, but typically, like I said, it's just to let your colleagues know, hey, how long is this really going to take you, and maybe who to rope in if it's extremely complex. State is also a way that we can categorize work items. It basically lets any project manager or stakeholder know what's been completed, or it might be what's in the works, and if there's a bunch of new stuff, you can, if you have free time, you can tackle what's new. However, my favorite element of a backlog item is essentially the tag. I think this is the best because you can tag backlog items based on technology or based on any free-form string, to be quite frank. Typically, in our deployments, we've used tags to tag things like Active Directory, Exchange, or Office 365, just because we have different subject matter experts on our team that want to do different or develop in different types of technology. So that allows them to filter on exactly, hey, this is the stuff that I want to get going on. I don't really care about anything else. And as your backlog grows, you can execute a query to show you exactly what you want to see. And after we understand the idea of a backlog, we want to start mentioning, some branching strategies or some, one of the fundamental things behind source control. Branching is essentially another fancy way of saying a direct copy of something. Typically, the way that things work is that there's a multi-branch strategy in many source control environments, typically having a master branch at the very top level with the highest level of quality required, maybe a development branch underneath that where things are probably working, but might not be polished. And then below that, we have a feature branch. Feature branches are where all of the work is actually being completed at. It's where you're actually introducing new files. It's where you're developing on existing files. And to kind of highlight that, I want to kind of go through the life cycle of what might happen during a given effort. So, for example, I might be in the development branch currently, and I say, this file could really use my expertise. I know how to make it much better. Maybe it's, cleaning up someone else's code. So if I create a feature branch from development, what that does is essentially it copies the development branch or that repository exactly as it sits, but it allows me to change it without affecting the branch that I actually branched from. So it allows you to develop in isolation. If you were to be adding new files, this would be the place to do it at. Otherwise, we can do our developing, changing files through commits, through, we're seeing how we're continuing to evolve in our own feature branch. And once we get to a given spot where we say, this is great, I think I've completed my effort, and I want to let everyone else know that's using the development branch that I've made an update. That's achieved by something called a pull request. Now, when we think about what a pull request actually is, it is, if you were to sit on the development branch, physically imagine yourself there, you're pulling in the changes from the feature branch. So it's essentially a merge of what's been done in the feature branch, and it goes into the development branch to catch up the development branch on what efforts you have been working on. Finally, as kind of like a last step then, is you would actually do that same action as a pull request into the master branch. And that would allow, again, maybe the master branch is possibly public facing, maybe it's used in a client environment, and again, it's just another gate to implement, your level of quality. So you heard me use some terms here. Committing is definitely a staple of source control, and at its heart, when you're committing something, it's really like you're saying, hey, this is an atomic unit of change that I want to wrap up and bundle. Because with source control, you can actually save locally as many times as you would, just like you're working on a Word document. Save incrementally so you don't lose your local work. But when you commit something, that's essentially saying, take all of these changes I've just done, wrap them into a single unit, and make that all of those changes referenceable at a single atomic level. Alternatively, there's the idea of stashing. Stashing is basically, maybe I'm developing and I've done some local saves. I've made some progress, but I don't think that I've quite reached an atomic unit of change. But I need to go do something else. I can't commit this, but I need to exit the branch that I'm currently in. So stashing basically is literally you're sweeping changes under a rug. You're not actually they're being undone from your current branch, and it says you'll be able to retrieve them later. So to solidify that idea, I want to kind of walk through an example. So say you're on your feature branch and you're doing your work, right? And you notice, and you branched from your development branch, and you find a bug actually in development. So that means that bug is affecting everything that you're doing in your feature branch. And maybe during your testing, you're not going to be able to move forward unless you alleviate this bug. So if you do a stash, what you can do then is all right, I can safely put away my changes in my feature branch. I can check out and correct the bug directly in the development environment. And then after that, I can go back to my feature branch, right? So after that, you can see that I can apply all of those changes that I have stashed under the rug, and then I can go back to my working environment and continue to work. Now, in order to make sure that you don't have a merge conflict, you really want to do a concept called rebasing. And rebasing is essentially saying synchronize with the above branch that I was just working in.
And David, you talked about committing, you talked about stashing, we talked about branching. Can you maybe just, I'm thinking through the scenario of, what happens if you're in your feature branch and somebody above you in development makes a change?
Exactly.
How do you consume that change?
Yeah, that's exactly the concept of rebasing here that we alluded to, but in a little bit more detail. Here's another example. So say that we are in our development branch. We've created our new branch. Again, we're committing. We're off to the races and making our changes in our feature branch. And someone else on our team has actually done a pull request into development before I could issue my pull request. So the key point here is saying that now we've become out of sync in a certain way. And again, the way that we solve this problem is by doing something called rebasing. So it basically says, I really meant to start here. Give me all the changes that are currently in the development environment and apply them to my current branch. And what that does is it synchronizes your working branch and the feature branch to development, and it applies your commits that you've been working on commit by commit so that you can peel them back if there was some sort of conflict. After that, when you do issue a pull request into development, there would not be a merge conflict in that case because you would have already been synchronized. Now, the key thing here is if you are collaborating on a feature branch or for any branch in that matter that requires a rebasing, you really want to have a high level of communication there because there's the opportunity that you steamroll someone's changes based on the rebase. So the rule of thumb that I particularly follow is that don't rebase a branch unless you're currently the only one working on it. And if not, make sure you get in writing or you have some sort of high communication with your peers so that you can make sure that you're not going to mess anyone else's efforts up.
It's a good way to make people mad.
Yeah, exactly. So we've gone through kind of the idea of how a source control branch evolves, how you branch from a development environment into a feature environment, how you can commit and move forward with your changes, how you can stash if you need to, and kind of like the last element that we want to talk about is if you were to implement any kind of review policy. I think that this is actually one of the most powerful features of source control. And what makes VSTS so great is that you can implement review policies based on identities in Azure Active Directory. So as our example, so say we are in our master branch and right now nothing is available for us. Like this scenario, our master branch is completely unaware of our current efforts. And we want to continue to we want to add into develop, or we want to add a file. We want to change something in our development branch. What that means is, as we continue to go down, we can, maybe we change in our example here. And make sure that we can. I just want to make sure that our colleagues can follow along here on the slides.
Hey, Johan, would you mind flipping that slide? Thank you.
Thank you very much. So again, this is a scenario. Our master branch is kind of unaware of our efforts because it doesn't even realize that our AB file is there yet. It hasn't been pulled into master yet. Now, We've created our feature branch, and we've basically changed our AV file to AC through a commit. Now let's say, okay, no, it's better that we change it to AD. So this is, again, just kind of how a file might change from commit to commit in a very simplified manner. And then we actually issue our pull request up to development. So now we've seen how AB has changed to AD. And during that pull request into master, we can actually implement a code review that's required in order to ensure quality. Now, the way that Visual Studio Team Services is supported code review is basically you can add required reviewers if you want to at an individual level. And in that case, every single required reviewer would be exactly that, required to approve the pull request. Or if you didn't want to have that level of scrutiny, you could also have a group that's assigned to be a required reviewer. And in that case, all that would need to be completed is that one reviewer would need to approve it of that group.
Yeah, and I think the most important thing we want people to walk away with is that we think code review is really important. It's not necessarily the bureaucracy around it. That's great, but we really want to make sure that, as we're going to production, or master, that's when peer review takes place. We think that's a place to catch bugs, catch sloppy code, catch security issues, that kind of thing.
Exactly, and I mean, there are other products out there that can serve as a source code repository for you, but this idea of a code review or a stop gate between branches is exactly what takes your developments to the next level. And you can document this policy and it really ensure that whatever is in that master branch, whether it's client-facing, whether it's internally facing, but there's a high level of quality expectation there, it's definitely the means by which that is ensured.
And David's going to touch on this later, but there's also an opportunity to automate some of this review with unit testing, like using PowerShell tester and that kind of thing.
Yeah.
So,
once we get big picture, we'll show you some larger architecture where you can implement some cool stuff. So we've talked quite a bit on the source code, the repository side of things, and now I want to talk about the other side. So VSTS is only half of the equation. Visual Studio Code is actually going to be the IDE that we use to hook into VSTS. For one, Visual Studio Code is great because it's platform agnostic. It runs on Windows, Linux, as well as Mac OS. And I'll give the caveat that our presentation here is on Windows. Visual Studio Code has an extension gallery, much like the Chrome Web Store has extension gallery. You can use this to personalize your own installation of Visual Studio Code, from anything like the PowerShell extension that allows some great IntelliSense and PS script analyzer functionality, or if you just wanted to change the look of icons, there's extensions for that as well. So it allows you to go way past what the ISE provides, and actually it basically gives you no excuse to be using the ISE anymore, as Visual Studio Code is definitely the new hotness from Microsoft in terms of a development environment.
Yep.
Now, I don't want to say that VS Code is only to be used for PowerShell development. Of course, it's a text editor at heart. It can be used with any language, whether you want to start using Python, Ruby, R, anything, but primarily we're using it for PowerShell. It's definitely the main tool that we use in that case. Mm-hmm. So now, Visual Studio Code and Visual Studio Team Services alone is not enough to make this configuration complete. So there are some auxiliary tools that are required in order for us to complete the installation. Obviously, we're going to need Visual Studio Team Services with Git as the back end as our source control engine. We're going to need a repository that has all of our library files in it. We're going to need a tool called Team Explorer Everywhere, the command line client that allows a hook into VSTS from any text editor. Now, for better or for worse, that command line client is dependent on Java. Yeah, I know it's another thing to maintain and keep updated. But hopefully the script that we will demonstrate to you guys will alleviate that installation and upkeep process. And lastly, there's the PowerShell extension, and that extension gives you particularly that PS script analyzer functionality, which is it goes even further than the grammar checking and the syntax checking than the ISE. It'll tell you, you're never going to be using GCI again. You're gonna type out get child item every single time. Now, when you see those green squiggly lines, it's probably going to annoy you, like it does for me if you're a perfectionist. But so now that we kind of understand these components that are needed, we're actually going to show you exactly the steps that are needed to be taken in order to complete this configuration. So initially, the only prerequisite here in the demo is that you have actually created a repository. Repository creation is absolutely free on Visual Studio Team Services. You can create a repository directly if you go to visualstudio.com/team-services. That'll give you the splash screen that you can create one. I've created numerous repositories for my personal accounts as well as our West Monroe accounts here at work. But again, the prerequisite here is that a repository has been created. After that, basically, we move on to the application level configuration. So at West Monroe, we did actually create a script that does a lot of the configuration for us because, to be honest, going through the TechNet articles and the Microsoft articles, it's somewhat cumbersome to assimilate all of these auxiliary tools, configure them the correct way, and make sure that we have some level of standardization between our teams. So
for anybody that's passively listening, now's a good time to grab a screenshot because that'll let you capture that link.
Yeah. Once we get the slides back on the screen, I would encourage you to download our script. Given the asterisk that it is, there's no warranty implied with this, but it has been extremely helpful and it's been working for us. What happens is when you do actually launch a PowerShell session as an administrator and launch the script, it will download Chocolatey to assist with some package installation, and it'll actually install VS Code, the PowerShell extension, set some path variables, and some other items like that. And however, during the running of the script, that you will be prompted for some user input. I'm sure that you could automate this part for your own particular organization, but in order to make it kind of more agnostic, we said, okay, there's two elements where we need to actually have some required input. One is, okay, what do you want to call this folder on your local machine? So you have to give it a project name. And the other one is, what's the URL that I'm actually going to be cloning the repository from? So that's going to be different for everyone. Mm-hmm. But again, if you want to standardize this for your own team, hard code that into the script, no worries there. So, as you can see on the bottom of our screen here, assuming that we have created a repository and we've run our script, the next step is actually to sign in using the Visual Studio Team Services extension. So I'm actually going to demonstrate this in a demo somewhat here to show you how to complete the configuration. And in my virtual machine here, we are exactly at the point to where we have ran our script, but we have not gotten any further than that. And so the way that you continue is, again, the slides will detail this, but you actually have to sign in using the command palette. And once you've run the script, a command called team sign in will be available. Hold on, gotta
keep your mouse there.
Yeah, there we go.
Yeah, hard to see, but it just says team sign in.
Yeah, let me 1 second here. And all right.
You got to kill that pop-up.
Yeah, there we go. Yeah. So yeah, the pop-up sometimes I got to suppress it, but after we do that command palette, the team sign in command, we authenticate with a new experience down here to get a machine token, and that'll allow this machine that you're working on to continually connect and authenticate back up to your repository. But what you need to do is copy this string.
So if you guys aren't able to see that, no worries. It's just like if you have a multi-factor authentication token, it's a one-time password that David's going to enter.
Exactly, yeah. And you go on to this this device authentication page that's presented to you in the dialog box, and I say, here's my code. And yes, Visual Studio Team Services is exactly what I want to connect to this device. And now it's going to ask you, okay, what are your Active Directory credentials? Great. Let me see if I can remember one of my accounts here. And hopefully I typed that in correctly. Yep, it looks like I did. So now, if you look down here in the bottom, I'll try and zoom in for you. You can see that on the bottom of my Visual Studio Code instance, I actually am now connected to this NSCUG demo repository that I have. Also, down here in the bottom, you can see that I'm in the master branch currently. And in general, this ribbon down here will change from purple to blue whenever you're connected to a remote repository. And that's exactly the goal that we have. And so at this point, right now, I have actually completed that configuration so that we, if we return to our slides here, we have entered our team sign-in, we have copied our code, and we've authenticated using our domain credentials. So actually, we are completely configured right now. We have hooked in our Visual Studio Code installation to our Visual Studio Team Services deployment, and we're ready to rock and roll.
Now, I will say, David already mentioned this, but we ran the script here at West Monroe to get this tool rolled out to our folks pretty quickly. It's not perfect. There are some one-off scenarios that we encountered where people have unique machine configurations, and of course the script had some issues in those cases. So your mileage may vary, but generally speaking, if you've got some PowerShell skill, you should be able to kind of figure out what's happening there, and you should be able to tweak it for your environment.
Yeah, and to that point, I'm not a heavy Twitter user, but give me an excuse to help you online. If you want to mention me or something like that, I'd be happy to help you walk through any issues you have. Screen grab your error, email me, whatever you want to do. This is the kind of stuff that I enjoy. So happy to help there if you do run into issues. And so with that, I know we went pretty fast through things, but we're actually going to continue this demo. We're going to review some of the concepts that we talked about earlier, creating a backlog item, creating a feature branch, making some changes and issuing a commit, submitting a pull request, and then, of course, approving that pull request as well. So with that, I'm actually going to break out of the slides again and go into my virtual machine. And again, maybe I say, I have that functional library, right, that we use as part of a network effort with PowerShell. So if I go ahead and open this in a text editor here, give me 1 second, just to grab the content of it, and I return back to Visual Studio Code, what I can do is within our demo repository, I can create a new folder. Maybe I just call this networking. And within this folder, I can create a new file. And maybe I call this network functional library.ps1. Cool. And I just developed really fast there. I just put in all of those changes. But you get the idea that this would be the location that you would you can make your changes. If you had an existing file, this is where you'd be updating things. And I'll take a pause here. So you notice some of these status bar indicators here on the top left corner. This indicator means that you have one change that has not been saved locally. And this indicator means that there is one repository change that has been made that you have not synchronized. So tracing back, when I created the folder networking, that updated the need to synchronize with our repository. And when I actually inputted the text of our functional library, this indicator says, hey, you have not saved that locally yet. And as a general reminder, you have one file that's with changes outstanding that have not been saved. So again, let me just go ahead and save this now. And if I save it locally, you see that went away up here. And now, okay, I'm at the point where I said, okay, I'm done making changes. I completed all of my development efforts, and now I want to commit them as a bundled request again. So we go back to the idea that you can have many local saved changes, but when you commit, those changes get bundled together. Mm-hmm. So in order to commit, I'll show you the workflow to do that now. So if we go ahead and click the source control icon within Visual Studio Code, there's many ways to skin the cat here, but I'll show you the one that I do, which is kind of the long way, just to make sure that everything is done properly. I can first, what I do is I stage my changes. I say these are the changes that I want to commit, put them up and be ready to be bundled. After that, I will commit staged, and the message I'll give here is for the demo.
This is asking you for what does the commit represent? What's the purpose of this commit?
Exactly, and some more advanced users know that you can actually tie commits to backlog items, which is pretty cool. That's a pretty, not advanced feature, but a little bit of a nuance within committing. Happy to go further into that again on Twitter if you have questions on how to do that. But you know,
So you basically hashtag the work ID, the work event. Number,
exactly.
right?
Yeah, and you know, to that point, what I'll actually show you is within our NSCUG demo here, I can create a backlog item probably as fast as anything. Work item. Let's just call this a feature. And this awesome feature. This description is I am the best.
And good at spelling.
Yeah. Yeah. There we go. Don't look at me too much.
Oh, you fixed it.
Yeah.
Darn.
So again, once you save this backlog item, you can actually go into the backlog and open up the item. You can see, yeah, I've already kind of got some in here. But if I click this feature, where is it? Backlog item number.
Probably, yeah, you're not showing the column, right?
Yeah. I'm just not showing the column, but you know, there's a backlog work item number that's always associated with it. Let's see if we can get to it this way.
Yeah, I wouldn't sweat it too much.
Yeah.
I do think that's a cool feature, though.
Yeah, but going back to our virtual machine here in VS Code. So, wrong window. So I know we were around a little bit, you know, all over the place there. But the idea is that you can commit and tie to backlog. But after you commit, I want to draw your attention to something. Actually, let me get this window because down here, after we committed, you can see that this synchronization icon that's right here, it changed from having a 0 and a 0 to basically a 1 next to the pending change. So what this means is that I have one commit that is ahead of the branch that we branched from on the remote side. And so the next step is, now that we've committed this, we've bundled these changes and created this commit, what you would do is you could actually synchronize with the master branch, or synchronize with whatever branch that you're in. And after the synchronization happens,
It might be hard to see, but there's a little progress in the upper left. Little progress thing that's moving across the screen. There we go.
Yeah, and you can see that on the synchronization window, you know, now we are here. See if I can get in. Yeah, that file explorer it's knocking me out. But if you pay attention down here, you'll see that there's no other pending uploads or downloads. And now, if we actually go back in to the branch, the master branch, you will see that we actually can view our network functional library up here now. And to that point, what I'm going to do again is show you how now you could issue some sort of pull request. So now that we have this idea of committing and synchronization with the remote repository, you can always, again, switch branches. I have this pre-created branch here for the demo itself. And when I change branches, you'll notice that when I go into the available files that I have, you can see that networking folder is no longer there. So what I'm going to do is I'm just going to speed through, just a basic change. And, we have our install Visual Studio Code script here that we alluded to earlier. And what I'm going to do is I'm just going to say these are some changes. Save those locally. Go ahead and commit all. And committing. And so now you can see how we just went through that workflow extremely fast on the demo branch. I'll synchronize my changes. And once that completes, I'll go back into Visual Studio Team Services.
There you go.
Yep. And if I look at the demo branch now, and I look at the raw, you'll actually see that those changes are present there. Now, I think that these changes are master worthy. So the way that I would enable that to get into the master branch is if I go into branches and I issue a new pull request, I can pull the demo branch into master, give it whatever notes I want to. It's going to take the last message that you used as a commit by default, and I will create this pull request.
And this is where, David mentioned this earlier, but this is where, you can put some governance around that process.
Exactly.
So and if you want to have an explicit reviewer review and approve it, you can do that.
Yeah, you can implement governance by doing something called branch policies. Branch policies, again, allow you to say a minimum number of reviewers. You can also have branch security, meaning like access control at a more traditional level, saying that maybe only a subset of users is even allowed to view the contents of a given branch. But once we've issued a pull request, there's still the idea that you need to approve and complete it. And again, those are the gates that allow the policies to be affected. And so once you've issued the pull request, there's only 2 more clicks that essentially need to happen. Again, I'm allowed to approve this pull request. I know this isn't really proper change management, that my requester is the same as the approver. But once you approve it, you can, of course, complete it. Now, I'm going to go ahead and delete the demo branch after I merged it because there's no need to keep this thing around. And the good part about all this is there's a log behind it. Visual Studio Team Services says, David was the one that made all these changes. He approved it and he completed it. So in a more traditional environment, you'd be allowed to, view all of the logs and how things are changing. And to wrap things up with the demo, I'll show you that if we look into the master branch now, and we look into our install Visual Studio Code script, you can see that our changes are now available in the master branch. And so with that, I'm going to go into some final thoughts on what the next steps are. And, once you get this workflow down pat within your organization, the idea here is to expand even further. We've only really talked about the source control part of Visual Studio Team Services, but it's actually the entire repository platform allows you to do things such as automated build tasks as well as release tasks, which are in a more detailed words, building it allows you to manipulate these files in any way that you want to, whether it's utilize Pester to do unit testing on a branch, whether you want to sign your script files using the Windows SDK. There's a sign tool that's available in there. That was a really quick win that we actually got within our own organization. We implemented a build workflow on our master branch that says anything that reaches here, we want to sign it, and we want to actually have that be available in a couple of different places. So once your build completes, there's the idea again of releasing. Particularly in our case, we are big fans of Azure here, and the idea that I'm a big fan of Azure automation, and my thought is that if I can develop PowerShell in a source control environment, I of course want that pretty code to be available to me in Azure, and particularly in the form of runbooks or desired state configs. And so, of course, when you do a build item or a release, you can actually use PowerShell to govern the release task. And what that allows you to do is, of course, use the Azure RM commandlets, import or update a runbook directly, and basically take those files that you've been working on and put them in a usable place. And that kind of completes the circle of a lot of our efforts here. At a more primitive level, you might just deploy the files directly to a SharePoint Online instance or a file server or something like that to make the files available to just a more wider audience. But again, the idea that you can separate the repository that hosts the files from maybe a deployment area, that's kind of like the version next of this webinar. And again, if this sounds like it's something that's interesting to you, please give me an excuse to use Twitter, and I'd be happy to even maybe show off some of the PowerShell that we're using to enact the build steps and release steps. Lastly, I want to talk a little bit about licensing. So Visual Studio Code is absolutely free. The IDE is free itself to download. However, Visual Studio Team Services there's a somewhat nominal cost associated with larger teams. And what that means is we need to understand the license types with Visual Studio Team Services. First, there's the idea of a stakeholder license. Stakeholder licenses are free as well, but they provide very limited functionality. Typically, people that have stakeholder licenses are maybe project managers or scrum masters that really want to have a view into maybe the work items that are being completed, and maybe they want to check in on the code at a read-only level. If you want to do much more than that, a basic license is required. And a basic license gives you access to everything except, again, package management and test manager. Those concepts are much more applicable to traditional software development, like if you're doing load testing or automated simulations. But a basic license should cover you for all of your PowerShell development needs.
I think the reality is most mid-size IT organizations probably don't have much more than 5 people writing PowerShell code. So I think this is, in fact, free for a lot of organizations. If you're bigger, if you're really an enterprise, of course you might have more people developing and you might need more licenses.
Yeah, exactly. The sweet spot, if you're over 5, is 10 users. That's where you're only paying about $3 per month per user. If you are somewhere in between 5 and 10, or maybe you just want to add in users individually, there's a nominal cost of $6 per month per user, and that gives you a basic license at an ad hoc level. So if you can't commit to a certain number of users at a block level, $6 a month is somewhat of a drop in the bucket for enabling this formality and this level of maturity for PowerShell development. And with that, I'll kind of open up the floor to say, please contact us with questions, whether it's through Twitter, whether it's through LinkedIn, email, or directly here in the webinar. We'd love to give some time to answer questions now. So maybe I'll ask Johan or anyone else in the room. Was this getting anyone on the webinar jazzed to have questions about this? Happy to answer. If not, I can talk about linear algebra or something like that.
Okay. Well, I think key takeaways are, start using VS Code if you're not already. Mm-hmm. This is a really cool free platform for, being more than a lone ranger, I should say, of PowerShell development.
I'd say if you're at a team of 2 or more, implement this workflow, become a master at it, so that when you do get a large team, you have a governance behind the workflow. Your policies are already written, and you've already standardized your deployment, because those were the challenges that we faced when rolling this out. We were having a struggle with the user adoption because we didn't have our governance and standardization enacted. But as soon as we found the means by which to do that, everyone was on board with it. And now we have, I think that we got 35 individuals on our internal PowerShell library development. So we got a lot of participation from West Monroeers.
Okay. Any questions come in? All right.
All right, with that, I think that we're going to break for about 10 minutes or so before the next session begins, and we will pause now and resume again in about 10, 12 minutes.